Bismillahirrahmanirrahim. Assalamu alaikum, dear students, viewers, teachers, and students. Welcome back to my channel, Cambridge CheMuneeb. Today I'm going to make a new video on the new topic of today, which is about the paper 1 second variant of May June 2024, as you can see on the screen. Before that, I made a video on the variant first of this paper, which you can see on the screen. So here, this is my channel preview, and you can find out the first variant of this paper. I have made two different parts of this video, part 1 and the second part. Alright, so now move to the to this paper without wasting a single time. Okay, so here the first question is, which pair or formula is correct? Before moving to the solution of this paper, the grade threshold, let me tell you, the grade threshold of this paper is 27. That's the grade threshold of A grade. Okay, now the first question is about which pair of formula is correct. We have been given options in the form of the compounds. We have the carbonates, nitrates, phosphates. So for this question to attempt, you need to know what are the actual formulas of the different ions. For example, here you have the formulas of the silver ion, potassium ion, zinc ion, and then you have ammonium ion, nitrate, phosphate. So here, yeah, you need to have the correct knowledge of the ions before constructing the right formula of the compound of these pair of compounds. So I have done the working for you. So let's skip to the working. Alright, here you can find the formulas of the ions. You should know that silver has +1 charge, carbonate -2, ammonium +1, nitrate -1, phosphate is -3. So using the formulas of these ions, I can construct the formula required for the compounds. Here it says, is it correct? Ag2CO3. So let's construct the formula. Ag has +1 charge. CO3 carbonate, which is called as carbonate, has -2 charge. We have to use this cross multiplication of the charges, and using this way we can find that 2 comes below Ag and CO3 is written without any number. So yeah, that's the correct formula of the silver carbonate. So I can say that silver carbonate is the correct formula. Whereas this ammonium nitrate, it is apparently seen that it is trying to say ammonium nitrate, but look at the way of writing the formula. Ammonium has +1 charge, nitrate has NO3 -1 charge. So here accordingly, if we say that these are the same numbers with opposite signs, then it should be written like NH4 NO3. It should be this should be considered as a correct formula instead of this one. So I will say it as incorrect. Why it has been considered incorrect? Because of the mentioning of the number 3 over here. It will be considered as incorrect. Now moving to the part B. The part B says it should be written as hydrogen. This is the hydrogen carbonate ion, HCO3. Okay, now SO3, as we can see here, has -1 charge and potassium has +1 charge. So these will be cross multiplied. So as a result, there should be no 2 over here. That's why this is considered as the incorrect. And for zinc phosphate, it is a right formula. Why is it right formula? Because phosphate has -3 ion on it. Now this -3 will go down to the zinc, and the charge of the zinc is +2. It will come down to the phosphate. So here we have 2. So that's why zinc phosphate is the correct formula. Then next formula, AgHCO3. Ag has +1 charge and hydrogen carbonate has -1 charge. So yes, that's the correct formula. Phosphate has -3, potassium +1. So after crossing their charges, this will be the right formula. and we can see that these two are correct. Let's check the final option, zinc carbonate. Zinc carbonate has +2 charge and the carbonate has -1 charge over here. So as a result, carbonate has a charge of -2. So considering that, that's a correct formula. But about ammonium phosphate, phosphate has -3 charge, so it should be 3 over here, not 2. So this will become incorrect. So that's why the correct formula or the correct option of this question is C option. Now the next question, number 2. How many molecules are present in 62 gram of solid white phosphorus P4? Okay, so here we have to calculate the number of molecules and we are provided with the mass of the phosphorus. We are given 62 gram of the phosphorus and the formula is P4, which means as you should know, the number of molecules is related with the number of moles. So we need to calculate the number of moles, and the number of moles is calculated by the formula mass over mR. The mass is given already, it is 62 gram, and the MR, relative molar mass of the P4 is calculated from its periodic table. So for P4, the atomic mass or the AR value of the P is 31. So we will multiply with 4 and you get the answer is 124. Okay, that's the molecular mass of the P4. Now we'll put the values in this formula. So it is 62 divided by 124 and the answer is 0.5. In other words, it is 1 over 2. Now they have given the equations in the form of the L. L means the number of molecules over here. So if the moles is 1 over 2, then that mole must be multiplied by the Avogadro's number of particles, which is 6.02 into 10 raised to the power 23. And in the literature, this number is represented by capital L. So that's why they have put the letter L in all the options. Now, since we have got 1 over 2, it means 1 over 2 multiplied by L. I will write 1 over 2 multiplied by L. It will give me the equation of C. So that's the right answer. Equation C is the right answer. Okay, moving ahead. The next question, number 3. This question is highlighted, which means this question is repeated from the past papers of May June 2019. And I have also searched the video on this question. So I have mentioned the links of the video on which these questions are recorded. So you can find the links in my description section, just like in my previously recorded videos. For example, if you look at the description of this unit part 1 of the paper 1.1, you can find in description that I have mentioned the links of these questions. The specific questions which were repeated, just like in this paper, these questions are from the past papers already, and some students or teachers have already recorded the guided solutions of these questions. So I have mentioned all the video links of all the questions below this video. So we'll skip this question and move ahead. Question number 4. So question number 4 says, in which pairs are both species free radicals? Okay, we have to find out which of these species are considered as the free radicals. Now for this purpose, it means we need to construct the dot and cross or simply the dots diagrams, the electron dot diagrams of all of these species. So I have done the working and I'm going to show you the real pictures of all the diagrams. Alright, so here's the diagram of the chlorine atom. You should know that chlorine belongs to group number 7, which means it has 7 electrons. Now we have to represent these electrons in the form of the diagrams. As you know, there is a rule to follow when one electron has to be shown, when 2, 3, 4, and up to 7 electrons have to be shown. When there are 7 electrons, then they are represented in the form of 3 pairs, 3 lone pairs, and 1 unbonded or non-bonded electron pair. So as you can see, there is 1 non-bonded electron. And you know which species are considered to be free radicals? Free radicals are those species which have at least they have one non-bonded electron, at least one non-bonded electron in the valence shell, and in this case the chlorine is considered as a free radical. Chlorine it will be considered as a free radical, so I can say this is a free radical. I am putting dot over here on top of it. It can be shown anywhere on the top side of the atom or the symbol. Now we have the number of species here. We have chlorine atom, oxygen atom, and in option 2 we have chloride ion, oxide ion. 3 has oxide with a single negative charge, and in the fourth option we have chlorine as a positive ion and oxygen as a doubly positive ion, which means we need to have the correct diagrams of all these different types of the species. Only then we can check which combination is the right one according to the options in A, B, C, D. So I'm going to show you firstly all the diagrams first. So as you know, chloride it has gained one electron, so all of its electrons will be shown in the form of the pairs. And afterwards comes the chlorine with a plus one charge on it. So it means it has lost one electron. Now, which electron has to be taken out from the chlorine atom when it makes the positive charge? It means we need to take out at least one electron from the three pairs. So I can choose any of the electron from the three pairs. We since I have three pairs over here, I can choose electron either from this pair or this pair or this pair. So yeah, I have to remove the electron. That's the electronic configuration says. If you remove the electrons, then the electron will first come out of in the descending order. Like what I'm trying to say that if I construct the electronic configuration of the second shell, then it is 2p x2, 2p y2, and 2p z1. So the electron, if I have take out electron, then I have to take out the electron from 2p y2, which I can say it can either be this pair or the any of these three pairs. One of these pair belongs to 2s, by the way. That's why we are seeing three lone pairs here. So I have to take an electron 2py. I don't know which of these three pairs is 2py, but at least one of them would be. So I will take the electron from any of these three pairs. So that's how I will get the chlorine ion over here. So I have got the real picture of the chlorine ion. Then comes the oxygen atom. The oxygen atom, as you know, belongs to group number 6, so it has 6 electrons. Now again, we should know the rule of showing the electrons of 6. So it will be shown in the form of two lone pairs. As you can see, there are two lone pairs and two non-bonding electrons. There are two lone pairs, two non-bonding electrons. So again, it will be considered as a radical. Yes, it is a radical. I forgot to tell which of these are radicals and which are not. That's not a radical because there is no non-bonding electron. That's a radical because it contains two non-bonding electrons. So yes, that's why it is a radical, and was also a radical, the chlorine atom. The oxygen, yes, oxygen has two non-bonded electrons, that's why it is a radical. Then we have to show the oxide ion. The oxide ion has three lone pairs, and actually it has gained one extra electron. Now that one extra electron must be accompanied this non-bonded electron or this non-bonded. So I have shown one of these in the form of the oxygen minus one charge. So I have got three lone pairs, but still there is one non-bonded electron. That's why it is a free radical. And then I have the oxygen 2 plus charge. Oxygen 2 plus charge means it has lost two electrons from its original oxygen atom. When it has to lose two electrons, then it means it has to remove electron according to the formula, according to its electronic configuration, which is 2p x2, 2p y1, 2p z1. Uh, we have 2s2, 2px2. That's the electronic configuration of its second shell. Alright, there is a slight mistake in my diagram. I have to redraw it. I'm going to raise one circle from here, and I'm going to put a lone pair over here. The reason is that If we follow this rule, then the electron, we have to remove two electrons. According to this electronic configuration of the oxygen, I have to first remove the electron from 2pz1 and then from 2py1. My mistake, again my mistake. I have to remove electron from the 2p, one electron from 2px2, because it is moving in the reverse order. The reverse order of adding the electron. As you know, the electrons are added from x to y, then z orbitals, and in the same way we have to show the electrons in the reverse order. So first electron will be removed from 2px2, and then the next electron will be removed from 2pz1. 2s2 will not be disturbed because it's in the lower subshell. That's why its energy is not changed. The electrons of the 2s subshell will not be changed. Only the electron of first 2px2 will be removed, and the first electron is removed from 2px2 and the second electron is removed from the 2pz1. So we are now left with one electron of the py and one electron of the x. So it means we have the lone pair of the 2s and we have the uh, one electron of px and one electron of the py. So I'm going to show over here in case of the 2s. This lone pair belongs to 2s. That's the electron pair of lone pair of the 2s, and this I can designate as 2px1. That's one electron of the 2px, and this one belongs to 2py. That's a one electron of p orbital. There is no electron of the 2pz because it has been completely lost, and there is just one lone pair. Now accordingly we have two non-bonding electrons here. We have one over here and one over here, which means that's a free radical. Yes, that's a free radical. And now at the last we have the oxide ion. The oxide ion with two negative charges, it means it has gained two electrons. The atom of the oxygen atom has gained two electrons, and now all of its valence shell has been completed in the form of the four lone pairs. Now you can see there is not a single non-bonded electrons, which means it is not a free radical. Now I have put the ticks and crosses on all the radicals, which means you can now easily find out the combination present in the options A, B, C, D, which will be considered as radicals and which will not be considered as a radical. I'm just going to zoom it out. Okay, now here we have the combinations. The chlorine is a radical. You can see over here. This is the tick over here. Oxygen is a radical. Yes. Chloride ion is a radical, and oxide ion is not a radical. Chlorine atom is a radical. Oxide with negative single charge is a radical. Cl plus is a radical, and oxygen with 2 plus charge is a radical. So, which of these four have all of them radicals? Option first, option third, and option fourth. All of these. So the correct option becomes the option A. This was a lengthy question to attempt just because to draw the right diagram. So I hope all of you have got the concept and understanding of this question. Now the next question, number 5, which shape is correctly predicted by VSEPR theory? Okay, over here we need to recall the number of bonded pairs and lone pairs with their shapes. Now here we are given there are two bonded electron pairs and there are two lone pairs. So if you remember, the right example of this is the H2O. H2O has, with the oxygen, has two lone pairs on it, and there are two single bonds with the hydrogen atom. But it is not a linear structure. You should know. I can also show in my notes the shape of this is either bent or V-shaped. That's why we always show the structure of the water in the form of this. is, you can say it is a V shape, or you can say it is a bent as compared to linear. If we force from one side, if we force from the central side, then it is considered as bent shape. So it will move sidewise, like it will move like this, and from here it will just like this structure. So it is not a linear structure. Then we have again same combination, two lone pairs and two bonded pairs. This is not a tetrahedral. Again, the actual shape should be bent or V-shaped. And at the last, if I see three bonded pairs and one lone pair trigonal planar, no, that's not possible. Because with three electrons and one bonded pairs, we have the example of ammonia, in which the nitrogen has one lone pair and there are three bonded pairs, and its shape is trigonal pyramidal. It's not trigonal planar, it's trigonal pyramidal. And that's why the correct formula becomes the C. Now I can show you through my notes as well. There is a complete table of the combination of the electron pairs with bonded and non-bonded. As this table includes only the bonded pairs of electrons with their shapes over here, and we have checked that when there are four bonded pairs, then we get the tetrahedral structure, and when there are only three bonded pairs, we get the trigonal planar. And in the next page, I have shown with their examples as well, when we have how many total electron pairs with their bonded pairs and with their lone pairs, with along with their examples. And you can see that for H2O we can either say as bent or V-shaped or non-linear. That's the right way of saying the shape of the water. These are my AS chemistry notes, and if anyone from you need this, you can leave the comment. You can reach me out on my WhatsApp number, which I have provided on this video as well in my description section. Now moving ahead, question number 6 is already attempted by someone else because it is a repeated paper. So I have mentioned the video link in my description section. Okay, now question number 7. In this question, it should be assumed that nitrogen behaves as an ideal gas under the conditions stated. Which volume is occupied by 1 gram of the nitrogen at 50 degrees centigrade and at a temperature of 120 kilopascal? Okay, so for this purpose, we need to recall the formula which is applied on the ideal gas equation, where the formula is PV is equal to nRT. We need to use this formula, but that's not straightforward used over here. Instead, we have to amend this formula. Uh, we are given the mass over here, we are given the temperature, we are given the pressure over here, and we need to find the volume. But here we don't have the mass mentioned, which means we need to devise another formula from this equation. The formula will become PV. This can be modified into PV is equal to mass over relative molecular mass into RT, and then after rearranging it we get the formula of V is equivalent to, because we have to find the volume, V becomes the mRT over relative molecular mass times pressure. Okay, that's the actual formula. Now we are given the nitrogen here. Nitrogen means it is N2. The relative molecular mass of this N2 will become 28 gram per mole. And then we are given the temperature. Temperature is 50 degrees centigrade. We cannot use the centigrade unit over here. Instead, we have to convert into the Kelvin. So it will become 50 plus 273 to convert into the Kelvin. So the value will become 323 Kelvin. Now comes the pressure. The pressure over here is in the kilopascal. The unit of this pressure is kilopascal, which means the value, as you know, the equivalency of pressure with volume is, if we are given kilopascal, the value should be, the value of the volume should come in dm cube, and when the pressure given the unit of pascal, then the volume of the volume unit should be meter cube. That should be remembered. Okay, we are given the value in terms of kilopascal. Now I will apply I will put the values in the formula of volume. V has the value of 1 gram. 1 is the mass. That's the mass of the nitrogen. 1 into the value of R is 8.31. 1 into 8.31 into temperature, which is 323 Kelvin, divided by relative molecular mass, which is 28, times the pressure, which is 120. The value comes out to be 0.7988. Now this is very much equivalent to 0.799. Now the correct answer becomes 0.799. Now the question number 8. The question number 8 says consider the following four compounds. Number 1, it is the organic compound. Number 2 is also an organic compound. Number 3 is organic compound. Number 4 is also an organic compound, but it is of hydrocarbons. This one is alcohol and this one is thiol. SH is the functional group of thiol, and this is first one is also is a hydrocarbon. Now the question is, what is the order of increasing boiling point of the compounds lowest first? It means we need to find the boiling points of these organic compounds in an orderly way. So let's start with working on it. As you know, the boiling point of hydrocarbons are always the least. We have two hydrocarbons here. Hydrocarbons mean those which contains only the carbon and hydrogen elements and no other element in them. So these two are the hydrocarbons. Within these two hydrocarbons, we need to find which one has lowest. Basically, if you recall the knowledge of the hydrocarbons, those which show compactness, we say compactness. Those compounds which show the compactness have the more ordered fashion of showing the intermolecular forces or van der Waals forces between them, whereas those which have more branching, let's suppose this first molecule has a branching in it. You can see this is structure of the first hydrocarbon. Because of this branching, there come some gaps between these molecules, and as a result, the compactness is weakened here. There is less compactness of the hydrocarbon of the molecules as a whole. Like this molecule will show less bonding with the other similar molecule, and as a result, the van der Waals forces will be weakened, whereas there will be greater van der Waals forces for this hydrocarbon, which has a linear shape here. There is least branching in this compound. So we know where the van der Waals force is. The greater the van der Waals force is, the greater the boiling point. So yeah, the compound number 4 will have more van der Waals force, will have more boiling point, and as compared to compound number 1. So considering that, you can see that the compound first will have the least boiling point. So there are two options in which one is showing least boiling point as compared to fourth molecule. After these two compounds come the compound number 2 and 3. Now in compound number 2, you can see there is a functional group of alcohol. And alcohol, as you know, the smaller molecules of alcohols can show the hydrogen bonding. There are hydrogen bonding in the molecules of alcohol. And hydrogen bonding is the strongest type of the intermolecular force. So we can say that this molecule should show the greatest boiling point value amongst all these four molecules. So which means number 2 should have the highest boiling point, and there are two such options, B and D, and 3 is lower than 2. Now, the option B now has all the options in an ordered way. So the correct option becomes the B. Now the next question, question number 9. Ethane can react with fluorine to produce 1,2-difluoroethane C2H4F2, and we have this chemical equation in which the ethane is reacting with fluorine molecule to produce this difluoroethane plus HF molecule, and enthalpy is given. We are then provided with a tabular form of the bond energy values of different covalent bonds in this chemical equation. What is the bond energy of the CF bond in 1,2-difluoroethane? Okay, so in this case, we need to find the CF bond present in this molecule C2H4F2. We are not given that value in this table, so we have to find that. Now this is kind of a numerical based question, and we need to do it in a stepwise. So I'm going to show you the working, and I'll also explain the working as. Alright, so here's the working. We need to find the value of CF bond. For that purpose, we use this formula, as that for my own convenience, I have used these words here: uh, bonds broken minus bond formation, bonds broken minus bond formation. This is the most simplest formula I use always to find out the enthalpy value in that case where the bond energy values of the covalent bonds are given. So we need to find those bonds which are broken and those which are formed. As you know, when the reactants are converted into the products, then the bonds of the reactants are basically broken, whereas the bonds are uh, of the products are formed. These are always formed. So we need to do the calculations in terms of the bonds values. Okay, so here the first molecule is ethane. We have to find the bond energy value or the enthalpy value of this whole compound. We can take the values from the table given. I have calculated all the values. 350 belongs to carbon-carbon bond, and 410 belongs to the carbon hydrogen bond. 6 times, because there are 6 carbon hydrogen bonds here. And then second molecule is basically the molecule of the product. This is the product and this is the reactant. The products are formed. Here here we have that bond which we need to find, the CF bond. There are 2 CF bonds present here, this one and this one. However, the rest of the bonds are the values of the rest of the bonds can be calculated from the given table. So after putting the values, I get 1990 plus 2 times of CF. This is the 2 bonds of the CF here, because we have 2 CF bonds. Now after that, I can also find the values of the 2F2 molecule here. The 2F2 comes from the table. Simply multiply this 2 times FF, and for HF I have to multiply with 2. So yeah, 2HF. So then I can construct the equation over here. The equation is broken minus formation. So the molecules on the left hand side are the bonds broken, or in other words, these are the reactants, and in the right side these are the products. So putting the values, I get this equation. uh, 4960 minus 960 is equal to 12 minus 2CF, and after simplifying it I get the value is 486. That's the final answer, and that's why the option is C. The next question, number 10. Which equation has an enthalpy change equal to the standard enthalpy of formation of the sodium oxide? We have to recall the definition of the enthalpy of formation. It says that 1 mole of the product, 1 mole of product is formed. So considering this definition, we can exclude some options. Here in option A, you can see that there is half of the Na2O formed, which means it is not the right answer. And in case of option D, we have 2 moles. Again, it is not possible according to the definition. Now, we are left with option B and C. We can see that in option number B, we have 2 oxygen atoms on the reactant side and there is 1 oxygen atom on the product side. Now we see it is not balanced, which indicates the right answer is C, in which the definition perfectly holds. And now the question number 11, nitrogen dioxide reacts with water. We have this equation. Which statement about this reaction is correct? Okay, so in this equation, we have to exclude the options and also consider the right option. The first option says both the products are formed because the oxygen atoms gain electrons. Both products are formed because oxygen atom gains electron, which means we need to check the oxidation number of the oxygen. Over here, the oxidation number of oxygen is -2 for one atom. It is -2 over here. It is again -2 here and -2 here. There is no change in the oxidation number of oxygen, which means this is not the right answer. Then option number C, the oxidation number of hydrogen is increased. Okay, so for hydrogen, the oxidation number is +1 over here, +1 over here, +1 over here. Again, it is not changed, so it is again not the right answer. D option says water acts as an oxidizing agent. If it acts as an oxidizing agent, then either the oxidation number of hydrogen or the oxygen should be changed, which we see here it is not changed. It indicates that this option D is also incorrect. Now the last option is B, which says the nitrogen atoms undergo disproportionation. Disproportionation means a single element being oxidized and reduced in the same chemical equation. So nitrogen, I need to write the oxidation number of all the nitrogen atoms present here. It is +4 here. It is then +3 here. We can calculate the values because it is -4 and this is +1. And on the right over here, if it oxygen is -6, it is +1, then it is +5. So what we see that the oxidation number of nitrogen has been changed from +4 to +3 and +5. So from +4 to +3 it is reduction, and from +4 to +5 it is oxidation, which indicates the definition of the disproportionation. So yes, the right option is B. Then our next question number 12, phosphorus reacts with concentrated sulfuric acid to produce phosphoric acid, sulfur dioxide and water. Then we have this whole equation. A, B, C and D are all whole numbers. The equation can be balanced by using the oxidation numbers. What is the value of A, some A, B, C, D and E? Okay, so here in this case we need to balance the whole equation. After that we will sum up all the coefficients which are present in the form of A, B, C, D and E. Okay, so how can we balance this whole chemical equation using the oxidation numbers? Uh, First, you should see that whether this equation is already balanced or not. What do we see here? First, the rule is that whenever we have a chemical equation in which there are elements other than carbon, hydrogen, and oxygen, then we always look first for those elements to balance. So, in this case, those elements other than carbon, hydrogen, and oxygen are sulfur and phosphorus. So, we see that sulfur and phosphorus both are already balanced in this chemical equation. Now the last one are the meaning one are the hydrogen and oxygen, which need to be balanced. But I'm not going to balance them right way because the question states that we need to use the oxidation numbers to balance them. So yeah, we need to put the values of the oxidation numbers over here, and we know that in most of the cases only the elements other than carbon, hydrogen, oxygen show the change in oxidation numbers. So over here we have sulfur. So the oxidation number of sulfur is +6 over here, and the oxidation number on the right hand side of sulfur is +4. So you can see there is a change from +6 to +4. Then for phosphorus, it is 0 on the left hand side, and on the right hand side the oxidation number is +5. Why is it +5? Because it is -8 and hydrogen is +3. So I get +5. So the rest of the hydrogen and oxygen have the same oxidation number, they are not changing. So what do we see here? That phosphorus has been changed from 0 to +5. There is an oxidation here. And on the other side, the sulfur has been changed from +6 to +4. There is a change of this value. Okay. For such type of equations, we need to check the electrons. The electrons can be associated with the oxidation and reduction. Phosphorus has been changing from 0 to +5, which means it is losing electrons, so I can write -5 electrons being lost here. And for the reduction of sulfur, I can write addition of 2 electrons because they have changed from +6 to +4. Now we have to balance this equation in terms of the electrons, so I will balance these electrons. There are 5 on one side and 2 electrons on the other side. So the electrons can be balanced by using the numbers here. I will write 2 over here and 5 over here because these multiples will give me 10 electrons each. 10 electron here and 10 electrons here. As you know, for such reaction, the gain of electrons should be equal to loss of electrons. Only then the reduction and oxidation reaction becomes valid. So gain and loss of electrons should be equal. Okay, now as I have checked the values which need to be multiplied, I have to multiply the same values with the species or with the substances for which I have found the value. What I mean to say that if I say that 5 is being multiplied with the electrons, then this 5 should be multiplied with the sulfuric acid here, and it should also be multiplied with sulfur dioxide here. That's the rule of balancing. So 5 is multiplied with these two substances. Now uh, for the oxidation reaction of phosphorus, I have multiplied with 2, which means I have to put 2 over here and also put 2 over here. Now these numbers have helped me to balance the phosphorus and sulfur, but now I am left with balancing the hydrogen and oxygen. Okay, now on the left hand side, let's calculate the number of hydrogens. There are 5 times 2, 10 hydrogens here, and on the right hand side, there are 2 times 3, 6. So I put 6 over here. There are only 6 hydrogens on the right side, which means I can choose a number which will be multiplied with H2O to balance it with 10 hydrogens. So it is simple. I will just write, I need 4 hydrogens, which means I will put 2 over here. This will give me 4 hydrogens. So 6 plus 4, 10 hydrogens. So hydrogens are balanced now. Let's check the oxygen. Oxygen on the left hand side are 5 4 20. There are 20 oxygens. Now on the right hand side, there are 2 times 4 8 plus 5 times 2 10 plus 2 times oxygen plus 2. So I get 20 oxygen again, which means this equation is balanced in terms of the atoms as well. Now I can simply write the values which I have used to balance. So as you can see, A is 5, B is 2, C is 2, D is 5, and E is 2. Now after adding all these values, I get 16. So 16 is the right answer. Then comes the next question, number 13. what volume of ammonia produced against time is measured into experiment. The volume of ammonia produced against time is measured two times. Okay, so we have this equation in which the enthalpy is given. Then it says that there were two experiments. In experiment number one, there were 3 moles of hydrogen gas, 1 mole of nitrogen gas at 45 degree and this pressure. Then the graph was plotted for the ammonia formation, and after that, the second experiment was performed, but it varied according to the one condition only. And we are given the graph of experiment number two. We are then asked, how does experiment 2 differ from experiment number 1? So it means that we need to find out the condition which change the graph of the experiment number 2. There should be only one condition which must have changed the graph. So if you compare the graph of experiment number 1 with 2, we clearly see that the speed of the experiment number 2 has increased because the change in time is less for the experiment number 2 because there is a steep slope over here. It means experiment 2 was faster. And the second thing we see, the difference see, is that the formation of ammonia is less, or the volume of the ammonia is less in experiment number 2. So we have to find those conditions which have put these differences in experiment number 2. All right, so the statement number 1 says that iron catalyst is present in experiment number 2. Okay, so if we say that iron is present, then definitely the speed of the reaction has increased. We know that catalyst increases the speed of the reaction by providing an alternative pathway of lower activation energy, but according to the graphs, the value of the volume of the ammonia has been decreased here in experiment number 2, which indicates that it is not the reason, it is not the condition, because the volume of NH3 has been decreased in the graph, so it is not the reason. The option number 2 says 2 mole of hydrogen gas is present in the reaction mixture in experiment number 2. Okay, I think in my opinion, it is my personal opinion, although there is no yet official um, update on this paper. In my opinion, it is not the helium. Instead, it should be the hydrogen gas, because the experiment is of nitrogen and hydrogen gas to make ammonia, and there is no link of helium in this chemical reaction or this equilibrium reaction. So I think it's a mistake on the part of Cambridge. The time will prove it if it is a mistake or not. But in my opinion, it is a hydrogen gas, not the helium gas, which is present. So considering that, if we say that 2 moles of the hydrogen gas was present, which means we have reduced the mole of the hydrogen gas in the reactant. So if we reduce the mole of the hydrogen gas in the reactant, then it should definitely have an effect on the formation of ammonia, which means the value of the ammonia gas will reduce. That is correct. The value of the volume of the ammonia gas will be reduced. That is correct. But we also need to check what will the effect on the rate of the reaction. So there is no such effect of the on the rate of the reaction, because when we decrease, there is no change in the rate of the reaction, because the rate changes because of the temperature and catalyst and the pressure. The rate changes because of these, not because of the presence of the less number of moles. So this is not the correct option. To B option is incorrect. Now the C option, that a pressure of 250 atm is used in experiment number 2, which means the value of the pressure has been increased. 200 has been changed into 250. So if we say that the pressure has been increased, so yes, the rate of the reaction increases. The rate of the reaction increases because of providing more pressure. But by providing more pressure, the Uh, but by looking at the chemical equation, we see that there are 4 moles on the reactant side and there are 2 moles on the product side, and increasing the pressure will shift the equilibrium towards the right side, which means towards the lower pressure or towards the lower moles. That's the principle of Le Chatelier's. That's the Le Chatelier's principle, that if we increase the pressure, as we know, pressure is directly proportional to the number of moles. If we are increasing the pressure, it means we are increasing the number of moles, and the equilibrium will shift towards that side where there are less number of moles, or in other words, there is less pressure, and it is shifting from left to right. There is an equilibrium shift from left to right, and on the right side means more ammonia is being formed. However, in the graph we see that there is less volume of the ammonia in the experiment number 2, which means that's again not a right option. Now the D option says that temperature of 600 degrees centigrade is applied as compared to the 45 degrees. So it is such a high value. So considering that, uh, we know that temperature, uh, when temperature is increased, the rate of the reaction increases. That's right, but we also need to check whether it will show less amount of ammonia. So yes, we can clearly see here that the enthalpy of the reaction is exothermic. It is an exothermic reaction, and for exothermic reaction, increasing the temperature basically reverses the reaction. It moves to the opposite side, towards the backward direction, reverse reaction. So in the D option, the because of the presence of the exothermic case, the reverse reaction will happen, and when it does, the ammonia will change into the original reactants of nitrogen gas and hydrogen gas, so less ammonia will be obtained. So that's why the D option is correct in this question. Now the next question, number 14. Which reaction has an equilibrium constant Kp that has no units? In my opinion, that's the simplest question here. Why is it so? Because we know that the equilibrium constant is simply the ratio of the concentration of products divided by a ratio of the concentration of the reactants. That's a simple chemical formula, mathematical formula of equilibrium. And those chemical reactions in which there is no unit, it means uh, the power of the products and the reactants should be same, and when they are same, they are cancelled and you get 1 as a value which has no units. So we need to find which chemical reaction has similar number of moles, and these power are basically the number of moles. There are 2 moles of the A, 2 moles of the product, which means there are 2 moles of the reactant and 2 moles of the product, so they are same. For B option, there are 4 moles on the reactant and 2 moles on the product. This will give you the units because they are not same moles. C has 2 moles of reactant, 1 mole of product. D has 3 moles of reactant and 2 moles of product. So the only correct option is A, in which the number of moles of both reactants and the products are same. Now the question number 15. Gas Q decomposes slowly at room temperature. We have this chemical reaction. Boltzmann distribution curve for gas Q at room temperature is shown. Which change occurs when a catalyst is added to gas Q? Alright, so here we have Boltzmann and we have this chemical reaction. It says what happens when catalyst is added for this chemical reaction, or you have to find what change will occur in this Boltzmann curve when catalyst is added. The options given are the peak of the curve moves to the right on the diagram. The peak of the curve moves to the right. As you know, and according to my notes, I should show you. In my notes, you can clearly see that when the temperature is the peak basically shift towards the right side, and towards a downward direction. That's the change in the peak. By applying more temperature, the Boltzmann distribution curve has changed in the peak shift from left to right and towards the downward direction. Whereas in the part it says to the peak of the curve moves to the right, so it is not the right answer because it happens because of the application of temperature, not because of the catalyst. Then C option says the kinetic energy of the unreacted particles increases. The kinetic energy the kinetic energy of the particles means more energy or the molecules present uh, at the more energy side. Basically, when temperature is increased, there are more number of molecules present which have energy equivalent or greater than the activation energy. So, at high temperature, the molecules have more kinetic energy, not in the presence of a catalyst. So, the option C also become incorrect because it is because of the presence by applying the temperature. The D option says the value of the activation energy decreases, moving the vertical dotted line to the right on the diagram. Now we have to check the application of catalyst. Okay, now again back to my notes. You can see that there is a Boltzmann distribution curve graph here, and you can see there is a mention of cat overhead, which means catalyst, and this activation energy is in the presence of catalyst, and this activation energy is in the absence of the catalyst. So by using the catalyst, the value of the activation energy has been changed. It has moved towards the left side, and as a result, there are now more number of molecules. There are more number of molecules as compared to the time when there was no catalyst. So by using the catalyst, have energy. More molecules have the energy, and you are also looking at the position of the dotted line is moved from right to left. However, in the D option, it says that the value of activation energy decreases. That is a correct statement. That is a correct fact. However, moving the vertical line to the right is incorrect. It does not move to the right. Instead, it moves to the left side. And then the last option is B. The number of particles with enough energy to decompose increases. Okay, now that is a correct statement because when we employ the catalyst, then more number of particles have energy to decompose, or more number of particles have energy equivalent to and greater than the activation energy, as seen in this graph over here. More particles are now present. These are more extra molecules which have energy equivalent equivalent to or greater than the activation energy. So the right option is B. B is the right option. Now, question number 16. Which statement is correct? Aluminum chloride has a giant ionic lattice of aluminum 3 ion and chloride ions. Okay, aluminum chloride, if we recall the knowledge of the aluminum chloride, then AlCl3 has not the ionic structure. You can have the idea from my notes. Uh, Here, there is a complete table in which there is mentioning of the structure of aluminium with the chloride. Aluminium with the chloride. So over here we have simple molecular structure. So it is not the right answer. We do not have a giant ionic lattice of the aluminum chloride. That's incorrect. Then the B option, sodium chloride dissolves in water forming hydrogen chloride and sodium hydroxide. Now again my notes, the reaction of sodium chloride with water is not possible. They do not react. they only dissolve in water, and as a result, the pH of the solution is 7. So there is no formation of the sodium hydroxide. So what we can say that the option B is also incorrect because uh, it it does dissolve in water. Sodium chloride does dissolve in water, but it does not form the hydrogen chloride or sodium hydroxide. That's incorrect because the pH of the solution remains 7. Then C option, the strong covalent bonds in silicon chloride prevent it from reacting with the water. Now back to my notes. The silicon chloride is a there is a violent reaction between silicon chloride and water which gives off HCl fumes and solid SiO2. So that what happens when silicon chloride reacts with the water. Uh, so it is incorrect that it prevents it from reacting with water. That is incorrect. The last option is when phosphorus chloride is added to water, the resulting solution conducts electricity. Let's see that. And in this notes, you can see that when PCl5 reacts with the water, there is a violent reaction, and as a result, the HCl is produced. Now, you should know that HCl is a very strong acid. So, being a strong acid, it completely ionizes in water. It completely ionizes in water to produce hydrogen ions and chloride ions. And because of the formation of complete strong positive ions and negative ions, it can conduct electricity. It can conduct electricity because of the formation of the hydrogen ions and the chloride ion. So yeah, because of this reason, the resulting solution can conduct electricity, and as a result, the D option is correct. Then question number 17. A mixture of calcium carbonate, nitrate, strontium carbonate, and strontium nitrate is thermally decomposed. The decomposition reaction of each substance goes to completion. How many products are formed? Okay, so here in this case, we have to completely decompose all these given four compounds: the calcium carbonate, calcium nitrate, strontium carbonate, and strontium nitrate. So I'm going to show you the working. Alright, here are all the decomposition reactions of the calcium carbonate, nitrate, and these. Okay, so you can find all the products here. I'm going to label 1, 2, 3, 4, etc. to the similar compounds which are obtained in the products. You know, calcium oxide, there are two calcium oxide, I'm going to put one on them. Strontium oxide, there are two strontium oxides. Uh, then about the carbon dioxide, there are two carbon dioxide, and oxygens there are four, and nitrogen dioxides there are five. So the question was about how many different products are formed. So there are five different products formed here. So that's why the correct option is B. Now question number 18. W is a white solid that reacts with water to produce an alkaline solution. The addition of the two drops of sulfuric acid to this solution gives a white precipitate. What could be the identity? Okay, here in this case, we are given the four different compounds. We have to find which compound will produce the alkaline solution here. All right, so you know that phosphorus oxide is one such compound among these which will give you the acidic solution, not the alkaline solution, because it is an acidic oxide. So clearly the option D becomes incorrect. D is incorrect. Now we are left with four options A, B, and C because all these are easily dissolved in water and they are all basic compounds. So we need to find which of these will give you a white precipitate. So in this case, you should know that there is one single compound which gives white precipitate, and that is the compound of the barium, because barium sulfate is a white gives you the white precipitate. barium sulfate. So there is only one single option of barium here. So we will select this single option as the correct one. Then question number 19, chlorine gas is react with cold aqueous sodium hydroxide. Which statement is correct? Okay, this is the question of chlorine and nitrogen of sodium hydroxide. Always remember to just memorize the reactions of chlorine gas with the cold and the hot concentrated sodium hydroxide. You just need to memorize these two chemical reaction, and you can easily attempt most of the questions linked with this situation. So I'm going to write the chemical equation in which there is a reaction of cold aqueous sodium hydroxide with the NaOH. So these are the fixed products which are always made. So NaCl and NaClO plus 2H2O. These are always the products. Now the question says about the chlorine oxidation and reduction. So just write the oxidation numbers of chlorine here. It is -1 here and it is +1 here because oxygen is more electronegative. So oxygen is both reduced over here and it is oxidized in this case. Oxidize and reduce, and the correct option is A. Then question number 20, sodium is added to water to form solution Y. The pH of solution Y is measured. When powdered substance X is added to solution Y, the pH falls. Which two compounds could each be substance X? Alright, now this question is kind of tricky, and I hope this question will be added in the examiner report. Alright. First of all, you should know what should be the type of the solution when sodium reacts with the Y. It is definitely sodium, and sodium reacts with water. So definitely it is very much reactive with water, and as a result NaOH is produced, which means it is a very strong alkaline solution, or the pH value about 12 to 14. You will get this much value. Now solution this solution now contains powdered substance X, which means the X must be the combination of these four options, combination of the compounds given in these four options. Okay, what do you know about the type of reaction when these compounds are added with the NaOH, which means we need to check how this pH value will decrease, which means how the NaOH will be neutralized. In other words, it should be neutralized somehow. Only in that case the value of the pH will decrease. So we need to find how this will be neutralized by using the compounds containing the acidic property, because only acidic compounds can neutralize the sodium hydroxide solution. So here let's check the nature of these compounds. Right here in my notes you can see that aluminum hydroxide acts as an amphoteric, which means it can react with both acid and also with the base. So it is an amphoteric compound, which means this aluminum hydroxide has the uh, possibility and probability of reacting with the sodium hydroxide to neutralize it, because it is now acting as an acid towards NaOH. So it is correct. AlOH3 is correct compound for this purpose to decrease the pH value. Now about the sodium chloride and magnesium chloride. I told you already about the sodium chloride that sodium chloride can dissolve, but the pH value of the NaCl solution is 7. The pH value of the NaCl is 7. We just saw earlier that NaCl, when dissolved in water, it does not react, but it only dissolves to produce pH of 7 value. And just below that, uh, uh, this paragraph, we can see the dissolving of the magnesium chloride. And when magnesium chloride is dissolved, we get a pH value of 6.5, which means it is slightly acidic, weakly acidic solution. A weakly acidic solution is formed when magnesium chloride is dissolved in water, and the reason is the hydrolysis of magnesium hydroxide, and as a result, H3O positive, which is an acid, is produced. So coming back here, we can see that magnesium chloride can also decrease the pH value. So the option A becomes ticks, has two ticks, whereas none of the other has two ticks. So option A is the correct one. Now the next question, number 21. The table shows statements about some of the properties. So we have to match the statement with the explanation it holds. The first statement is iodine is a solid at room temperature. So yeah, iodine exists as a solid, and explanation is that the II bond strength is high. The II bond strength is related with a covalent bond, and it has nothing to do with the physical state of the molecule. If it is has mentioned the intermolecular force or the van der Waals force, then we could say that it is giving the right explanation. So the explanation is incorrect. Then option number B, the decomposition of the hydrogen iodide is more endothermic than the decomposition of hydrogen chloride. Now it is incorrect because hydrogen iodide has a larger iodine atom, whereas hydrogen chloride has a smaller atom of chlorine, and because of that, uh, the breaking of the hydrogen iodide is easier. It is not more, it should be less endothermic because it is easier to break bond of hydrogen iodide since iodine has a large radius. So it is incorrect. And then explanation, the chlorine is more reactive. Chlorine is more reactive than iodine. Basically, the statement is incorrect. However, this explanation is correct because chlorine is more reactive, but it is not uh, properly explaining the statement. So it is a mismatching explanation. Then option number C, when chlorine is bubbled into aqueous potassium iodide, a purple solution is seen. Okay, it means that chlorine is basically doing what? Chlorine Cl2 is basically oxidizing the iodide ion, and that is correct. Chlorine can iodize, but it says that as a result, purple solution is produced. That is incorrect. All right, in my notes, it is written here that the color of the iodine in solution varies with the solvent. In non-polar solvents like CCl4, C6H14, it is the same color as a gas. So the color of the gas is same, which means it is the purple color in both the cases when the solvent is non-polar. However, when the solvent is a polar, for example ethanol, and you also know that the water is also a polar molecule, polar compound. So in that case, it should be the brown color of the iodine solution. The iodine will exhibit brown color when we use the polar solvent. So in this question, it says the aqueous solution, which means it contains water. Water is a polar compound, so it should not be purple. Instead, it should be the brown color. So that's why it is incorrect. However, the statement is chlorine is stronger oxidizing agent than iodine. That is correct. This is a correct statement. Now the D option. When concentrated sulfuric acid is added to sodium potassium iodide, a purple vapor is seen. So here the color is according to the state. The color is purple when there is a vapor. So that is a correct statement. And yeah, when sulfuric acid is reacted with the uh, any compound of the iodine, let's suppose here it is Ki, then yeah, as a result I2 is produced in the vapor form with purple color. And why? Because iodide ions are being oxidized to iodine by the sulfuric acid. Yeah, that is correct also. because sulfuric acid works as an oxidizing agent here. So the correct option becomes D. Now question number 22. Which statement describes a property of an ammonium ion? Alright, ammonium ion has the formula NH4 plus. In this case, we can see that this has the possibility to give away its hydrogen ion. It can release hydrogen ion, which means it acts as an acid, not as a base. So this base thing is incorrect. That's why the option A is incorrect. The option B, that our aqueous ammonium sulfate reacts with dilute hydrochloric acid to make ammonia gas. No, that is incorrect because it is the ammonia gas test here. Ammonia gas test, or the presence of the ammonium ion test. In which case, in that case, it is not the acid which reacts with the ammonium salt, it is the alkaline solution which reacts with the salts of the ammonium ion. There's a salt of the ammonium ion which reacts with the alkaline solution to make the ammonia gas. So it is incorrect. And C option is an ammonium ion has a pyramidal shape. No, that is incorrect, and we have already seen the previous question of the initial questions that pyramidal shape is linked when there is ammonia. Example of pyramidal is ammonia, but this one is ammonium ion, which is just like the CH4, and CH4 has the shape of tetrahedral, in which the angle is 109.5 degree. So this 107 is incorrect. It should be 109.5. And D option is the four NH covalent bonds in ammonium ion are identical to each other. Yeah, that is correct because all the bonds in ammonium ion, they are all now identical and we cannot differentiate them. That's a property. Although we know that one of these bonds is a dative bond, one of which has a dative, I can assign either this or any of these four. That is a dative bond, and that dative bond is now just like a covalent bond. So yes, the right option becomes D here. Then question number 23. Catalytic converters are fitted in the exhaust of many cars. Okay, this question is highlighted, which means this is a repeated question of October 19 and it has been answered by someone else, of which link I have mentioned in my description section. Then comes 24. This question number 24 is also attempted by someone else. Then question number 25. The question number 25 says, which statement is correct? Adding sodium oxide to water gives a lower pH solution than adding silicon oxide to water. Alright, we know that the sodium oxide, when dissolved in water, produces the NaOH that is formed when the sodium oxide is added, and this will have pH value of around 12 to 14. Whereas when silicon dioxide is added to water, okay, now coming back to my notes, we can see that silicon oxide is insoluble in water and the pH value is 7. So we have seen that the value is pH 7 when silicon dioxide is added in water. So we will write pH value is 7. So it is incorrect. It is not the lower pH, instead it is a higher pH. So this A option becomes incorrect. Then option number B, the oxidation state of sodium in its chloride ion is higher than oxidation state of silicon in its chloride. Okay, chloride is higher in sodium chloride. Sodium, it is NaCl, and in the NaCl, the oxidation state of sodium is +1. Whereas in case of the silicon with chloride ion, the compound is SiCl4. Now silicon, if this is compound, then chlorine has -1 for one atom, and for 4 it will become -4. So to balance it, the silicon should have +4. So now it is again incorrect. because the oxidation state of sodium is +1 as compared to silicon, which is +4. So it is not the higher, it should be lower. So it is incorrect. B is incorrect. D says the melting point of chloride of sodium is lower is than the melting point of chloride of silicon. Okay, on one side we have the NaCl and on the other hand we have the SiCl4. NaCl is an ionic compound, whereas the SiCl4, its bonding is a covalent. SiCl4 has a covalent bonding, and it exists in the form of the liquid and has weak van der Waals forces. So this become incorrect, as the sodium chloride has the higher pH, has the higher melting point than the chloride of the silicon. So the correct option is C, because the atomic radius sodium is larger than that of silicon. So for that purpose, I can write the elements of the third period: sodium, magnesium, aluminium, and then silicon. That's from left to right, moving across left to right. So sodium has greater radius than magnesium. Magnesium has greater than aluminium, and aluminium has silicon. So sodium has a very much higher radius as compared to the silicon. That's why the correct option becomes the C. Before going ahead, I want to show you my workbooks or worksheets of all the units of AS chemistry as well as of the A2. You can see on the screen that it is the unit 1 of the AS chemistry. I have compiled questions of past almost 11 years from 2012 up to 2023, and you can see how well refined the questions are, with the mentioning of all the repeated years or references when the question came. And these questions also have the my examiner report questions, and they are also differently highlighted. For example, uh, here the font is different, so this question is present in the examiner report. And at the end of these questions, there are almost, you can see, there are almost 88 questions with just one single unit. And then comes the mark scheme, and after that it is followed by the examiner report. The examiner report contains all those explanations of the questions. And you can also get you can get these worksheets in the form of PDF from me directly. And if you want to get them in hard form, then you can get them from this MS photocopy shop, which is present in Islamabad at different points. For example, F10 Numericals, PWD, and in Rawalpindi, it is present in Bahria Towns, Phase 7, Sadr, and and in also in Lahore it is present in DHE Phase 2 with the contact number mentioned here. So that's the paper 1 or the MCQs portion of this chapter. And then comes the structure or the paper 2 or the structure questions of the same unit 1. And the questions are again very much in quantity. You can find a lot of questions of this one single unit. After that comes the mark scheme of the same chapter, and it is then followed by the examiner report of each and every question. So it will boost your preparation for your exams, and you can easily grab around. You can easily have a good command of the this chapter after preparing or attempting these topical worksheets of my AS. So the same I have compiled for all the chapters of the AS chemistry. So if you need these in the form of the PDF, you can contact me on my WhatsApp. Yeah, also you can also approach me. All right. Now next question is 26, and this is the first question of the real organic chemistry. The question is, Z is a gaseous hydrocarbon which has a density of this much under room conditions. This reacts with an excess of the hot concentrated acidified KMnO4, and only one type of the carboxylic acid is formed. What is Z? Alright, so this question is kind of tricky here. We need to find different things in this question. First of all, We have been given the reaction of these hydrocarbons with the acidified KMnO4. So, if you recall your organic chemistry, it says that we need to find the formation of the carboxylic acid as a result of this reaction. So, first of all, I need to show you the working in which all these different compounds have reacted with the KMnO4. So, here are all the workings. Okay, now over here you can see that in option A, the compound is butene and this is butene. I have not shown the hydrogens just for simplicity. You should know that all the carbons should have bonded with their required number of hydrogen atoms. Okay, so when the butene reacts with the acidified KMnO4, hot concentrated acidified KMnO4, then as a result you get a cleavage on this double bond point, and as a result there will be formation of carboxylic acids. So for the left side will give this carboxylic acid and the right side will give this carboxylic acid, and you can see that these both are same carboxylic acid, and the question was on the same thing that only one type of the carboxylic acid is performed. So these two of carboxylic acids are same. So apparently it seems that this is the right answer, but we should see the products obtained as a result of the remaining three compounds. Okay, the option number D, hex 3-ene. Let's start from here to continue with this part. The hex 3-ene is has this structure. Now, when this reacts with the acidified KMnO4, then you will again get a cleavage at this point, and there are three carbons on the left side, three carbons on the right side. As a result, you are getting same type of the carboxylic acid, which are propanoic acid. So these propanoic acids are formed. So both option A and D have given the same one type of the products. Let's check what type of products do you get from option B. Option B is 2,3-dimethylbutene. So this 2,3-dimethylbutene has this simple structure. Now over here, when it is cleaved, it will cleave over here, and as a result, you will again get one type of the product, but according to this structure, this is not a carboxylic acid, it is a ketone. So that's not your right answer. So B is clearly not your answer. And for option C, this is hex 2-ene. Now hex 2-ene will cleave over here, and as a result you will get this ethanoic acid, and on the right side there are four carbon atoms, which means you will get the propanoic acid on this side. Now we have got propanoic acid, but on the other hand we got, and the other product is phenol. These are not one type, so these are clearly not your answers. Now we have to check which of these two will be the right, either A or D. So to get to the right answer, we need to check the other data we are given here. We are provided the density over here, density. So density can be used in the formula of density is equal to mass over volume. We know that these four compounds are all gases. So gaseous compounds must be present at room condition, which means their volume will be either 24,000 centimeter cube or 24 dm cube. But which value should we use? We need to use cm cube because the density is also in cm cube. That's the reason we are selecting cm cube value. Now this cm cube, this formula will be rearranged into mass is equal to volume to density. Density is given, volume has been found. Now we multiply them with each other. You get 84 gram. Now that's the mass of the organic compound, which means we need to find which of these two compounds especially will have 84 gram. Okay, over here in butene we have four carbon atoms, and we have how much hydrogen atoms? 3, 3, 6, 6 plus 2, 8. We have 8 hydrogen atoms. if you add, if you find out the MR value of 4 carbon and 8 hydrogen, you will get the value of 56. You can use with the calculator. And the D is hexene, which means there are 6 carbon atoms. And how much hydrogen? 3 plus 3 is 6. 6 plus 2 10. And then we have 1 12. We have 12 hydrogen atoms. So when you find the MR value of this hexene, you will get 84, and this 84 is the same value which we got from the formula of the density. The formula of the density gave you the same 84 value over here, which means this was a gas which we were talking about. So D option is the right one. Now question number 27. Compound X can be oxidized to compound Y, and compound Y gives a yellow precipitate with alkaline. Which of these are the compounds? Okay, I don't know which compound will give you the this test, but you should remember that only the compound of this part, like what I mean to say, this part of the compound will give you the positive test of the iodine, the yellow precipitate test with the iodine. This should be the part present in the molecule, and this has been obtained from the alcohol by basically when there was group over here. This was converted into this by oxidation. So which means both these groups can give you the positive iodine test or positive yellow precipitate test. But we also need to check the first statement, that it should be oxidized to compound Y, and that would give you the positive test. So I'm going to show you the working. Here is the working. Now the first part, the option A, says it is butanol, which means it has 4 carbon atoms, and the alcohol is a primary alcohol. When it is oxidized, it will give you the aldehyde, and it can still convert into carboxylic acid, that would be a butanoic acid. So none of the butanol or butanoic acid will give the positive test with the iodine. So it is the incorrect. Butan C option is methyl propanol. Now this methyl propanol has this formula without the hydrogen atoms, especially the carbons. So when it is oxidized, then you can see that it is a again a primary alcohol. So it will convert into either aldehyde or further into carboxylic acid. But now this is not the group which needs, which this group should be present to give the positive test. So it is again incorrect. The D option is methyl propanol. This is the formula of methyl propanol. Now, when it is oxidized, it is not possible to give the product because it is a tertiary alcohol. It is a tertiary alcohol, and tertiary alcohol cannot be oxidized. So there will be no reaction possible. So we cannot find the positive test. Now comes the B. B is a butanol. This is a secondary alcohol. This secondary alcohol can be oxidized into the ketone. This is a ketone functional group present, and we can match this group. This whole group is the same as the one above to give the positive test for the iodine. These are same. So which means the B option is the right one. Now next question number 28. As you can see that it has been repeated 3 times, and I have included 3 to 4 videos links for this single question, so you can easily understand this question. Then question number 29 is also repeated, and its video links present in description. Question number 30 is repeated, it is present in the description. Then question number 31. The question number 31 is also repeated, and you can see it came in October number 2007. This question is repeated, but I have not found any person who have made video on the on this question. So I'm going to explain this question by myself. Now in this question, it says which reaction will distinguish between propane 1-ol and propane 2-ol. So this is propane 1-ol and this is propane 2-ol, which means the first one is a primary alcohol and the second compound is a secondary alcohol. Now we have to apply these tests on them. We have to acidify with CheMuneeb on these two. We have to acidify K2CO2 on these two. And in C option we have dehydration followed by bromine and then mild oxidation. So I'm going to show you the working. How can we distinguish these two alcohols with these four given tests? Alright, here I have given the letter A to the propane 1-ol and letter B to the propane 2-ol to make it simplify. When propane 1-ol is acidified KMnO4, then you will get this type of the carboxylic acid. It is the propanoic acid. And when the propane 2-ol will be oxidized, it will convert into this type of the ketone. This will be the ketone. So propane 1-ol is giving the propanoic acid and propane 2-ol is giving the ketone, but it is not that it is distinguishing them. It is simply how one compound is reacting with both. It means KMnO4 is reacting with the uh, propane 1-ol and it is also reacting with the propane 2-ol, so it is not basically distinguishing them. So it is not the distinguishing test to of these two molecules. Then the other is K2Cr2O7. You know that both KMnO4 and K2Cr4 they are both oxidizing agents, so the products will be the same. With one propyl, the product will be the same, and propane 2 will give the same product according to the first reaction. So it is again not possible to distinguish them. Now comes the dehydration followed by reaction with bromine. Okay, so in this case we are given steps. I will say dehydration the first step and reaction with the bromine the second step. So I'm going to apply these two steps on both molecules. In case of a molecule which is propane 1-ol, this is the first step. And in the first step, we are getting the dehydration, and as a result you are getting a propene, prop2ene, prop1ene, my mistake. Prop1ene is formed as a result of dehydration, and when this will be reacted with the bromine 2 molecule, you will get two bromine atoms on these two carbon atoms. Now apply this for the propane 2-ol, which I have shown as a as a B molecule. So in first step it is a dehydration for secondary alcohol. This is a secondary alcohol. So you will get the same type of the alkene product. So there is no difference between them. And when it will be reacted with the bromine, again the same molecule. So there is no differentiate between propane 1-ol and propane 2-ol using these two steps of the tests. Then comes the D option. The D option says you have to do the mild oxidation firstly and then react with the Fanning's reagent. Okay, now if we do the mild oxidation for the molecule A, then you will get aldehyde because it is a primary alcohol, so it can, and it has stated mild, which means we have to limit it. We have to limit the oxidation step, which means we will stop this at aldehyde formation. Now this aldehyde should be reacted with the Fanning's reagent, and Fanning's reagent, as you know, is a mild oxidizing agent. It will now convert into the carboxylic acid, and this is a positive test. Uh, and as a result, red precipitates are formed. This is a test for the aldehyde. Uh, and for the molecule B, which is a secondary alcohol, when it is mild oxidized, it will convert into the ketone. The same thing which happened in the option A and B, where it converted into ketone, but this time it will be further reacted with the Falling's reagent. Now Falling's reagent is a test for the presence of the aldehyde functional group, and ketone cannot give this test, so no reaction is possible with the ketone. So Falling's reagent cannot give the ketone cannot give reaction with the Falling's reagent. So this is a test step of the test which can differentiate between propane 1-ol and propane 2-ol. So that's the right option D. Then question number 32 is already attempted by someone else. Question number 33 is also attempted by someone else. Then comes question number 34. The question number 34 states the molecule of limonene has 6-member ring and this is the only cyclic component in structure. Which volume of hydrogen is required to react completely with C double bond in 1 mole of limonene? Okay, so it has given some information that the compound has this formula and it must contain 6-member ring. Alright, so we can assume that this shall be the 6-member ring which is present in the molecule. Now in this ring there are 6 carbon atoms. We need to complete the remaining carbon atom, which should be 4. So I'm trying to put a branch over here of 4 carbon atoms. 1, 2, 3, 4. So now there are 10 carbon atoms. Now I have to check uh, how many hydrogen atoms are there. I'm not including the carbon-carbon double bond. I'm just using without the carbon-carbon double bond. So there will be 2 hydrogen atoms here, 2 here, 2 here, 2 here, 2 here. This single 1 hydrogen atom here because there are 3 carbons and there was vacancy of 1 hydrogen. Now there will be 2 hydrogen here, 2 here, 2 here, and there will be 3 over here. Now in total you can count them 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. There are 20 hydrogen atoms present here. Now the concerning question had the concerning molecule has 16 instead of 20. So you have to somehow remove 4 hydrogen atoms and it can be done by employing carbon-carbon double bonds in the given structure. So I'm going to draw another molecule with the same number of carbon atoms, but I'm going to put carbon-carbon double bonds here. I will put one double bond here and another double bond here. Now, because of these double bonds, the hydrogen atoms will be reduced. There will be now one hydrogen here because there are already 2 hydrogen atoms. There are already double bonds of carbon, but there will be 2 hydrogen atoms in this corner. One hydrogen atom here, one here, and there will be 1 hydrogen atom here, 2 here, 2 here, 2, and there will be 3 over here. Now you can count hydrogen atoms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. There are now 16 hydrogen atoms here. So we have basically just by adding 2 double covalent bonds, uh, we have reduced the hydrogen atom to the required number. Now we can see that they are now 2 double covalent bonds. Now to reduce, it has say which volume of hydrogen at room temperature conditions required to react completely with carbon-carbon double bonds in 1 mole. Now we are considering that this is 1 mole of the molecule. Let's suppose this is 1 mole. Then how many hydrogen gas molecules are required to react? Alright, so one double covalent bond can react with 1 mole of the H2 gas because these double bond will convert to single bond and one hydrogen will come here and another hydrogen will come over here. Since there are 2 double covalent bonds, so we can say there will be 2 moles of the hydrogen gas reactive when there will be 2 times of the carbon-carbon double bond. Now we have selected 2 moles of the hydrogen gas. Now it should be converted into the volume. We know that 1 mole of any gas contains 24 dm cube. So as in our case there are 2 moles, so 2 moles times 24 will give you 48 dm cube. So that's why the correct answer becomes C. Now the next question number 35. 1 bromopropane reacts with hot ethanolic NaOH. What is the molecular formula of the product in this reaction? This question is again very much simple. we first need to construct the formula of the 1-bromopropane. Now this is 1-bromopropane with the relevant number of hydrogen bonded to carbon. Now when it reacts with the ethanol in the presence of the NaOH, then you should know that it gives the elimination reaction or dehydrohalogenation reaction, in which the hydrogen halide is removed, which in this case will be the HBr. HBr will be eliminated, so you will get this carbon-carbon double bond in our here. This is the carbon-carbon double bond. Now you can simply check that there are now 3 carbon atoms, and in total there are 6 hydrogen atoms. So that's the formula of the compound obtained as a result of this reaction, C3H6, and this is the A option, C3H6. Now question number 36. A sample of pent-2-ene-4-ol has this formula, contains all the possible stereoisomers of this compound. How many stereoisomers are there in this sample? Okay, for this question, you need to first of all draw the structure formula of this displayed formula of this compound, because only then you are able to look at in detail the whole compound. So I'm going to draw the structure. The structure of this and the display structure of this compound is C, single bond C, and then we have to first write down the whole 5 carbon atoms because it is pent. So I'm going to draw 5 carbon atoms. After that, it says the position of double bond is over here, and the position of the alcoholic group at number 4. So 1, 2, 3, 4. It is over here. You can put hydrogens. You can complete the hydrogen atoms here. Okay, now all the hydrogen atoms are completed. Now, stereoisomerism means it can contain both the geometrical or cis trans as well as optical isomers in this compound. So we need to find all the geometric as well as optical. As you can see here that there is a double covalent bond, and in this compound we have the hydrogen bonded upward, and the one I have drawn has hydrogens upward in the upward side, and this carbon has another group of CH3, and this carbon has this whole group as one. So considering that the hydrogen atoms are upward side, I can say these are in the cis position. This structure is cis, and if I take down one hydrogen and draw in the downward direction, then this will become trans. So at this position I can get the cis trans isomers. So as a result, there are now two stereoisomers. Two stereoisomers because of the cis trans. Alright. There is no other double covalent bond, which means there will be no other cis trans isomers. Now I have to look for the optical isomers, for which purpose I need to find the chiral carbon here. The chiral center. Okay, so the chiral center in this case is this one, in which there are 4 different groups attached with it. This is OH, this is CH3, and there is a one hydrogen present here, and then this whole is considered as one single unit. So this carbon is the chiral carbon, and as a result of chiral carbon we have two optical isomers, which means now in total we have 2. There is no other carbon apart from this one, so as a result we have 2 optical and 2 cis trans, and when we add them you will get 4. So that's why the C option is the right one. Now question number 37. Which pair of reagents reacts to form product with a chiral carbon atom? Again, we need to practice about the chiral carbon here. Alright, we are given the reactions. We will develop the products from these reactions, and then we can find. Okay, the first reaction is between this compound and HBr. It means it is following the Markov Nikov rule and anti-Markovnikov rule, which means the stability of the cations. The stability of cations. If it is according to the Markovnikov rule, then you will get the product in which the hydrogen will add on this carbon and bromine will add on this carbon. So I can write CH3 CBr. I'm writing the abbreviated form with C. This C means CH3. And the other product which will be against the Markovnikov rule, then in that case the product form will be CCCBr, which means the bromine has bonded with the right carbon. This bromine has bonded with the right carbon. So these are the two products formed. Now, if we try to find the chiral carbon here, there is no chiral carbon in any of these two products because there are no four different groups attached with any carbon. Now let's move to the next option B. It shows that it is the reduction reaction of the ketone. So when the ketone is reduced, you get the secondary alcohol. So a secondary alcohol is being formed as a result of this reaction, and there are three carbon atoms, so you are getting propane 2O. Now again, finding the chiral carbon. Here there is no chiral carbon because there is no single carbon with four different groups attached, because for the central there are two similar CH3 groups. Now option D. Option D shows that there is an formation of an Ester, and I'm writing its product in simpler form, C with C double O, which means it is ester linkage, and C. We have ethanol over here, so that this part is the ethanol. It comes from the ethanol, and the other parts come from the carboxylic acid. Again, there is no chiral carbon because all the carbons have somehow one or two similar bonds attached. It is CH3, it is CH2, and this has carbon double bonded oxygen and one bond over here and one atom over here, and this one has three, so no chiral carbon. Now about this structure or this reaction, we have aldehyde bonding reacting with the HCN. Then as a result you will get this simple structure which I'm writing here. The double bonded aldehyde, it is the aldehyde, it will be converted into the aldehyde functional group will convert into the alcohol functional group, and this carbon will be bonded with the CN. Now I'm completing the hydrogens. Now here you can see that this carbon is chiral because it has four different groups attached: OH, CN, and this whole one group, and then a hydrogen. So this will consider as a chiral carbon, and as a result, this C is the right option. Now question number 38. The diagram shows the structure of two esters X and Y that are formed in ripening apples. We have these two esters structures. Which carbonic acids are formed when these esters are hydrolyzed by sulfuric? Okay, so we need to find the products which are obtained as a result of the hydrolysis of these esters. Okay, again, you should know which part will give the alcoholic and which part will give carboxylic when hydrolysis is done. Uh, Hydrolysis will done on ester X at this point, and this part will become the alcohol, and on the ester Y this will be the cleavage point, and this part will become the alcohol. It is now decided these are the alcohol part. Now from ester X it indicates that you are going to get two carbons in the carboxylic acid. That's why the product will be the ethanoic acid, and in ester Y you are going to get carboxylic acid which has 1, 2, 3, 4, 5 carbon atoms. So I'm going to draw a simple structure of the carboxylic acid. This is the functional group of carboxylic acid, and in comes the next carbon. This is the same carbon. It has methyl group upward, and then it has two carbon atoms on the right side. Now this is the product obtained as a result of the esterification hydrolysis of ester. So from option A, we have these two correct options, A and B, and from ester Y, we are getting this type of the carboxylic acid which is mentioned in B and D, because this is the chain side group. My mistake, this is a branch or the side group. So as a result, the B option has two ticks, and this is the right option. Then question number 39, an addition polymer is made from monomer Z. This is the monomer Z. What is the structure of the polymer made from this monomer? Okay, you have to find out the polymer obtained as a result of the polymerization. Alright, first of all, you should know that the addition polymerization occur when the carbon-carbon double bonds are added with the carbon-carbon double bonds of the other monomer. In this case, as a result, the carbon-carbon double bonds are broken into carbon-carbon single bonds, and you get continuing bonds on the either sides. Okay, in this case, the carbon-carbon double bonds are present here. Now we have to add the other monomer from this point, and this part will become the side group. It will not be the part of the main, you can say, the backbone of the polymer. It will come as a side group. Now look at the option A. In option A, we are looking at this part. It is not containing any double bond in the original monomer, so it is not the right option. In B, we again have the double bond present here according to the B option, but it is not present here. There is no double bond here. And addition polymer occurs because of the carbon atoms, not because of the oxygen atoms. In option C, it has shown the some portion of this as a side group, but the actual part which it has to bond must be from this double bond. So the double bond which should added with each other will be this one, where it has shown a double bond inside the repeating unit. It is not possible. So again, it is incorrect. And the D option says the CH2 and CH2 are being added with each other. So yeah, that's the right option. CH2 will added with each other, and you are looking at the continuing bonds on the side, and this is coming as a side group. So yeah, that's the right option. D is the right option. Then last question is based on infrared spectroscopy. Now this infrared spectroscopy has this graph. This graph is basically, or I can say, this whole question is repeated just exactly the same as in this first reference. This question 40 is totally the same as in first reference. However, in second and in third reference, these questions are partially shown. Like this graph is a part of more than one graph. One graph will be the same one, this one, and the other graph will be different, but somehow these includes the explanation of this graph. So you can find these three different references with their video links in the description section to know how to attempt this question. That's why I'm now going to attempt this question. Now this paper is completely solved now, and I hope all of you have been benefited from my video. So at the end, I will request you to subscribe to my channel, because it is now at its initial stage, and will keep uploading more and more academic videos and videos on past paper practice and some uh, some of the specific question and also the lecture videos. So please subscribe my channel, like, share, and like and share with others. So I will come back with another video. So till then, take care and Allah Hafiz everyone. Thank you.